Hello, Math 96. So here we are back to math videos. So remember, if you're new to the class and if you have any questions about what we're doing, how to upload your images and things like that, I will talk to you after class. Make sure you go Guardian chat with me or chat in the Google Meet. So today's January 7th. And we're going to go ahead and skip chapter 4, you guys, and move on to page 53 in your white note-taking guide. And the reason for that is because chapter 4 is a big project that we normally would be doing in person. So if we get back to in-person learning this year, then we'll go ahead and do chapter 4. So if you can go over to page 53 in your white note-taking guide, we're going to be in your textbook, section 5.1. At the top of page 53, for those of you who are new, please write down the essential question: in what way can a polynomial function model a real-life scenario? And we'll be talking about that in our next video. So there will be actually 2 days for this lesson. My pen doesn't want to work. Let's see if I can get it to work. So this is day 1, okay? So you will answer the essential question, for those of you who are new, in the summary on page 54, but not until tomorrow. So today's just an introduction. You should be able to identify the naming of a polynomial based on the highest exponent. And then you should also be able to evaluate a polynomial in function notation. And we've already done that before earlier this year. So some of this is a review. It's a lot of vocab today, okay? So just pay attention to what I'm saying, where to look, whether you're looking at the exponent, the little number that's hooked to x, or if we're talking about the coefficients, which is the number in front of x, or if we're not talking about how many terms are in the whole problem. Okay, you do have homework. It's on page 286 to 287, 1 through 10, and then also number 58. For those of you who are new, all your homework comes out of the green textbook. But if you wait to the end of this video, I always show you the homework. So you really can just pause the video there and you don't even have to open up your textbook. So just wait till the last slide. Okay, here we go. So naming polynomials. So I'm going to just go over this. I first want you to write these words. So the first word is monomial. Mono, I know in Spanish means hand, but mono also means one. The next word is binomial, and bi means two. The next one is trinomial, and tri means three. And then after 3, we have for 4 or more terms, we just have a general word. It's called polynomial. Poly means many. It's polynomial. So this will be for 1 term. This will be for 2 terms. So binomial, you can think of bicycle. A bicycle has 2 wheels. Trinomial, you can think of a tricycle. It has 3, just like a tricycle has 3 wheels. This has 3 terms. And polynomial has 4 or more terms. So monomial is 1 term. So I'm just going to make up an example. That would be something like 4x squared. And the one trick that you're going to see on homework tonight is that that little exponent has to be positive in order to be a monomial. And I'll clarify that on the homework before the video ends. Okay, a binomial is 2 terms, so maybe you still have 4x squared, but then there's also maybe a number in the back, constant number. And then a trinomial is 3 terms, so maybe you have 4x squared plus 2x plus 5. So there's 3 terms. And then a polynomial is 4 or more, so maybe you have 7x cubed plus 4x squared plus 2x plus 5. So there's 4 terms. You could have 5, 6, 7, 8 terms. Polynomial just means many. Isn't that easy? Okay, so make sure you understand monomial is 1 item, binomial is 2 items, trinomial 3 items, polynomial 4 or more items. Okay, so this lesson is based on your ability to be able just to read math. And so don't be overwhelmed. I know there's a lot of letters and numbers and X's. I just want to show you this so that you understand when you get to college that this is just a way of a symbolic language. I mean, if you pick up any textbook in math, doesn't matter what country you're at, you'll still see the same setup. And so we're just going to talk about this. So here we go. We're going to talk about the degree being 0, 1, 2, 3, or 4. So let me just show you. Just listen for a minute. Degree 2. That means the exponent is 2. Degree 3. The exponent is 3. Degree 4. The exponent. Fourth degree. Third degree. Second degree. Well, what the heck, Miss Artofer, what's a 1 degree? Well, remember in math, there's always these hidden ones. So right here, this is first degree. Why is this one 0 degree, Miss Artofer? Well, because there's not an X. Okay, so that's what degree means. Let me just erase that. So the degree is based on the exponent. Let me give you some examples to make this easier. So a 0 degree does not have an X. So it could be something like f of x equals, I don't know, 7. So there's no X. Let's look at the next one, degree 1. So this does have an X. Still has this, we call this a sub 0, just like this one. So I'll put a 7 there. But I need a first term here. And this is just the coefficient, the number in front. So I'm just going to make it up. So f of x equals, all of these are going to say f of x equals. So let's just fill those all in. They all start with f of x. Remember, that's just a fancy way to write y. We learned that at the beginning of the year. F of x just means y equals. Like this one could be y equals 7. All right. Okay. So we need a first term, and then we need that constant, the a sub 0. So we'll just make it up. Maybe it's 3x plus 7. The next one, I need the same thing back here, but I need to add at the beginning an x squared. This one will start with x cubed, or x to the third. This one will start with x to the fourth. Okay? So this back part, a sub 1x plus a sub 0, is the same as right here. I just need to add in a front term. So let's just make that up. It needs to have an x squared on it. So, maybe negative 2x squared. Now go back and just use the part that we used right above it. So a sub 1x and a sub 0. So we'll just use the 3x and the plus 7. So the next one's going to start with x cubed. So it has all the same parts for this, but it needs to start with x cubed. Then it goes to x squared, x, no x, just like this one, x squared, x, no x, right? But first we need x cubed. So, I don't know, let's just make it 1x cubed. Now the next one is x squared, x, and no x, so we'll just use the one above. Here's the x squared, negative 2x squared, then the x, and then the number. Okay? So this one just needs to start with x to the fourth, and then we'll use the remainder of the x cubed from above. So let's just use, I don't know, 9x to the fourth. So that takes care of this front one for x to the fourth. And then we'll just copy down from above the 1x cubed, the negative 2x squared, and you do have to write small, the 3x, and the positive 7. You can kind of squeeze it in there. Okay, so that little bit of lesson was to try and help you to be comfortable for when you go to college with understanding what this notation means, right? So this is just the coefficient in front. In this case, it was a negative 2. And then next to it is the x squared, right? And then this one just had a plain x for 3x, and this was just our constant of 7, right? So don't overstress that. I'm just trying to help you read your math book. Okay, so what you do need to know is the names, the type, the naming of this kind of function. So if we just look at this one right here, let's start in the middle. What is something that has an x squared? What is that called? It always goes by the highest exponent. So this is x squared, this is x to that hidden 1, right? And no x. Anything with an x squared is called a quadratic. We are going to be studying quadratic second semester, so you need to know that word. So quadratic goes with degree 2, or this, it has to have an x squared. So what happens when you have an x cubed? Do you know the name of the function when it has x cubed? X to the third? That's called a cubic function. That should be familiar to you. Now this next one, when you have x to the fourth, this might be a new word for you. This is called quartic. Quartic. If it's x to the fifth, it's quintic. I don't remember what x to the sixth or seventh is. They all have special names. But you need to be familiar that x squared is a quadratic. X to the third is cubic. You should remember that from geometry. X to the fourth, you're learning that it's called quartic. Well, what if it's just x to that hidden 1? Or do you know what a graph looks like for 3x plus 7? That's linear. It graphs into a line. So that's called a linear. You graphed those ever since 9th grade, right? You've graphed something like, I just want to change it because I got rid of the x part on accident. You've graphed something like 3x plus 7 with me, right? So that's linear. And then what happens when you just have a constant? So f of x equals 7 or y equals 7. So when you don't have the x, well, it's actually x to the 0. That's just called a constant. Okay, but please make sure you're familiar with x squared is quadratic, x to the third is cubic, x to the hidden 1 right here is linear. Okay? All right, so that's some namings, and it goes by the exponents, okay? Make sure I didn't skip anything. Okay, you don't really have these two words right here. I added them in this morning. I just wanted to give a definition of those words for ascending and descending. So maybe you've flown on a plane. So if you think of about a plane taking off or landing, which one goes with ascending? Which one goes with descending? So ascending means the plane goes up. Descending is when the plane goes down. Well, Ms. Arthofer, we're not talking about planes. We're talking about math. Okay, so ascending goes up by exponent numbers. And remember, the exponents are these little guys, the little numbers, the numbers that are hooked to the x. And so obviously descending, it's going to go down by exponent numbers. So if you want to add these into your notes, a little definition, make sure you know what that is. All righty. So this says write the following function first in ascending order. So for A, we need to do this in ascending order. So we need to go for A, it needs to go, I hesitated, goes up by little exponent numbers. So look here, remember this is a hidden 1. So you want the exponents to go up. So we need the smallest one. Well, that would be this because it doesn't even have an exponent. This doesn't even have an exponent. So it starts at 8. Going up would be x to the 1. Going up would be x cubed. Going up would be x to the 4th. So it goes up by the little exponent. So no exponent, exponent to the 1, to the 3, to the 4. So this is your ascending order. Descending order goes down by the little exponent numbers, right? Goes down. So start with the highest. So now we're going to start with 2x to the 4th. Go down, negative 5x cubed. Go down by the little numbers. Negative 4x to the 1, right? And then the item that doesn't have an x. Okay, so ascending, x to the 1, x cubed, x to the 4th. Descending, x to the 4th, x to the 3rd, x, and then no x in the back. Okay? Goes up by the little numbers, goes down by the little numbers. Easy, right? Okay, so remember, you can always hit pause on the video if you need a minute to finish up your notes, and then just restart your video. Okay, so because I was trying to save some space, I did 2 problems at once instead of making example 2 and 3. So we're going to do this one at a time. First, we're going to find f of negative 2. So we're working in polynomials in chapter 5. We've already been over this. So how do you find f of negative 2? All that means is plug it in. You guys, it just means plug it in. So wherever you see an x, you just plug in negative 2 and then do the math. That's all. That's all you have to do. It's just a fancy way when we say find f of negative 2. It's just a fancy way to say plug it in. All right? So plug in negative 2 at the x's and then do the math. So f of negative 2, I'm just writing it out. Give me a minute. I'm putting parentheses where I'm going to plug in that negative 2. Just copying down the problem and putting parentheses so I can plug it in. Oh, I barely made it. Okay, so I'm going to go ahead and plug in negative 2 where the x's were. Now, if you have a calculator, it would be interesting to see what math you get from this. I always do that in the classroom. We're going to do it by hand. So now I need you to remember your PEMDAS rules. And I read your final exams. You guys said you were good at your PEMDAS. No parentheses. Well, it's just negative 2 inside the parentheses. Nothing to do. Do not multiply before you first have to do exponents. Do not multiply. Do not multiply 2 times negative 2. Do not multiply negative 5 times negative 2. That's the most common student mistake. You can't do that. You have to do the exponent. So right here, you have to do these exponents. So I'm going to bring down the outside 2. And then I'm going to figure out what's negative 2 to the 4th. So that means negative 2 times negative 2 times negative 2 times negative 2. Right? 4 times. So do this set first. What's negative 2 times negative 2? It's 4. Done. Do this set. What's negative 2 times negative 2? 4. Done. What's 4 times 4? 16. So right here for negative 2 to the 4th, we should have 16. Okay, do not multiply Do not multiply negative 5 times negative 2. Don't do that. Bring down negative 5 and figure out this part. Do the exponent. What's negative 2 cubed? Well, that's the same as this problem, right? except we have one less. So let me just erase it. All right, makes it easier for me. So what's negative 2 to the third? It means 3 times. So negative 2 times negative 2 is still 4, times the back negative 2 is negative 8. So right here for negative 2 to the third should be negative 8. Okay, there's no exponent here, so we can just do that. So 4 times negative 2 is negative 8, and I'm just going to bring this back one down for another negative 8. Lots of negative 8s in this problem. Okay, let's do our math. Left to right, follow the rules. The next thing, we're done with exponents, so you need to do the multiplies. So 2 times 16, let me change colors real quick, okay? 2 times 16 is 32. Negative 5 times negative 8 is positive 40. Bring down minus 8, bring down minus 8. Always work from the left to the right. Start over. 32 plus 42 is 72 minus 8 minus 8. 72 minus 8 is 60 is 54. Minus 8. Ooh, sorry. Wait. Sorry. I didn't mean 54. That's start over. 72 minus 8 is 64. So 72 minus 8 is 64, and then I have to bring that back one down, and 64 minus 8 is 56. So our final answer for f of negative 2, because that's what we were figuring out, how much is the function at negative 2? It's worth 56. And that's our final answer. If you're new to my classroom, FA stands for the words final answer. And instead of writing out final answer every time, I just write FA because it's important for you to know what is the expected final answer in this classroom. So if you're new, FA stands for, this is what you would write as the final answer on a test. Okay, so we did f of negative 2. Now I want you to do the second one, f of 3. Hit pause, please, and do it on, oops, sorry, hold on. Oh, come on, machine. Hold on. It's being picky. Let me try my mouse. My mouse works better. I had it set up. Hold on. Sorry. So f of 3 is equal to, I'm just writing the problem down from right over here, okay? So 2x to the 4th. So hit pause and you do it and see if you get the same answer as me. Hit pause. Do it on your own. See if you get the same answer as me. And then start the video again and we'll double check. Hit pause and do it on your own. Oops. Okay, so hopefully you're back now. This would be 2 times 81 minus 5 times 27 plus 12 minus 8. So that's 162 minus, what is that, 135, I think? Let me double check that with a calculator. 5 times 27. Yeah. Okay, so 162 minus 135 is 27. And I bring down plus 12 minus 8. So 27 plus 12 minus 8 on my calculator. So f of 3, I got 31. All right, 27 plus 12 is 39, minus 8 is 31. All right, that should be 39 minus 8, which equals 31. Okay, so that's evaluating a function. Calculator, here we go. Okay, so like I said, this is going to be your homework. So you can always look at this slide. I do want to clarify one thing with you. So this one right here, so remember a binomial, look over here, which one has 2 pieces? Trinomial, which one is 3 pieces? This one's a little confusing for the monomial. Is it A or is it C? So I just want to clarify that for you. So this is A. Now the reason that C is not a monomial is because it has a negative exponent. So that way it cannot be a monomial. I won't ever quiz you on that. I know it's a little tricky. So this one right here goes to C, goes to a term that is not a monomial. So I wanted to clarify that for you. Okay. So binomial, you're looking for a 2-piece, trinomial, 3-piece. This number 4 says a 6th degree polynomial. So you need something with, it looks like most of these are T's. There's just one with an A and an S, right? Most of them are T's. Okay, so a 6th degree polynomial, you need something with 6th degree, that's T to the 6, or S to the 6, or A to the 6, whatever letter they're using. Polynomial means many terms, so it has to have 4 or more terms, right? So 6th degree means something to the 6th. A polynomial, many terms, written in ascending order. A polynomial, many terms, with a lead that has degree 5, 5th degree, so something with T or X to the 5th, degree 5. Now be careful, this one's a polynomial with a leading coefficient. So that means the number in front, this is the coefficient of 5. Degree is exponent. Okay? A cubic polynomial. Cubic means T to the 3rd. Okay? So you try and match those up for me. And then you have to do number 58. I need you to find g of 3. And when you're done with that, also find g of -1. This is the same as f of x. They can call it f of x or g of x, h of x, okay? So same thing as what we went over, you guys. Please make sure this homework is done today. Appreciate it. Have a great day and a great weekend.